Good day to you all out there. You are welcome to Science Explained. Um, Today, I want to quickly give some tips on how candidates writing West African Senior School Certificate Examination in Nigeria. I want to give them some tips on the practical physics they will be having tomorrow. If you can follow these tips to the very letter, I can assure you of getting at least 45 out of 50 marks meant for the physics practical. The first thing you need to know is that after you have performed the experiment on the practical questions given, out of the 3 questions, you have to attempt any two. But whichever one, number 1, your table of values. Your table of values is very important. Let's say, for example, you have mass, which is m. You must indicate the unit. Of course, when you are performing the experiment, you will be using grams. You can't use kilograms. So you have to put that unit there. Without putting this unit, you are losing marks for this column. So let's say this is time t, unit of time, which is the standard unit, seconds. You must put it on top. Without putting this, you have lost marks for these columns. Let's say you evaluate period t, which is equal to time t over number of oscillation. You have to put the unit, which is also seconds. Without putting the unit on top here, you are losing marks. Okay, let's assume that you have to evaluate t squared, that is square of the period. Then that means it will be in seconds square. So if you don't put that, you have lost marks. That's one. Now look at this column for mass. You know that you'll be given the masses, the slotted masses to be used. All this one must be to 1 decimal places. 1 decimal place or 2 decimal places at most. If you want to use 1 decimal place, it has to be 1 decimal place all through under this column. If you want to use 2 decimal places, it has to be 2 decimal places all through under this column for mass. If you mix it up, you have lost mark. For the time, that one also can be 1 decimal place or 2 decimal places. Now, the readings that can be in 1 decimal or 2 decimal places are the readings you take directly by yourself while performing the experiment, because it might not be time, it might not be mass, it can be length when you are measuring. But as long as you are the one who measures it out, who takes the reading by yourself directly, it must be either 1 or 2 decimal places. Take note of that. Any other parameters that you now evaluate through those ones that you are taking directly, that is the direct readings, any one you evaluate, such as period t and the square of period t, any one you evaluate must be in either 3 decimal places or 4 decimal places. 3 decimal places or 4 decimal places. That means if you are using 3 decimal places, it has to be 3 decimal places all through this column. It is 4 decimal places, it has to be 4 decimal places all through this column. The same thing here. In case of electricity, it can be, for example, current. Let's say this is the current, which is amperes, and let's say the resistor you use, you are given, where that is resistance, which is in ohms. So you will notice that the current are the readings you take directly from the ammeter. So this must be 1 decimal place or 2 decimal places. I'm trying to explain to you what I mean by direct readings. Okay? And in voltage, which is in volts, is also direct readings from the voltmeter. So 1 decimal place or 2 decimal places. Now, the resistance is evaluated. How? By using this and this. Remember, V is equal to IR from Ohm's law. That means R will be what? V over I. So whatever you get for your resistance, you are evaluating it. That means it must be 3 decimal places or 4 decimal places. So that's what I meant by the ones you evaluate. Now, that is the first part. The next is the graph itself. Now, after you have prepared your table of readings, the next thing is to draw your graph. How do you draw your graph? You can lose marks on this aspect if care is not taken. Number one, I'm using a graph, assuming I'm plotting a graph of mass against period square or square of period. I have to indicate what is on the vertical and what is on the horizontal. M in grams with the unit, T square in second square on the horizontal. This is half mark, this is half mark in Y. Then the arrowhead you are seeing here, this arrowhead, if you don't put them, you have lost 1 mark. Take note of that. The scale you use to draw your houses, you have to write it. If you don't write the scales, then you have lost 2 marks. The title, that is mass against T square, as in this case. That is the vertical against horizontal. Take note of that. So if you don't write the title, you have lost a mark. Then, after you have taken care of all those, let's assume these are the points that you got while you are plotting. It is not, in fact, in most cases, all the points will not fall on the graph drawn. The graph drawn in physics practical is called line of best fit. So what do I mean by line of best fit? Line of best fit means the line that passes through some points such that the ones that do not fall on the line are equally displaced on either side of the graph drawn. That means if, for example, these 3 points falls on my graph, you make sure that the graph is drawn so that it cuts through the axis. Take note of that. So you notice that these 2 points that are not on the graph, they are either side of the graph, 1 here, 1 here. And also the gap between them to the graph must be approximately the same thing. That is what we mean by line of best fit. If the line you draw does not, follow this rule, then you have not drawn a line of best fit. Therefore, you will lose mark. Lastly, if you want to take slope, what if the points you have on the graph drawn are spaced out, as in this case? I will advise you take the last and the first point as your scale for the slope rather. But if the points are very close, such that the gap between them is not much, I will advise that you take any neutral point on the line, as long as the gap between them is much. What am I trying to say? Anytime you want to choose point for your slope, you must ensure that the slope covers more than half of the length of the graph. Therefore, if I choose this now, these are this. So that means I will draw a broken line from that down, I will draw another broken line from the other point to meet it. So do not draw thick lines, because thick lines show that they are part of the graph. Let the triangle for your slope be broken lines. Take note of that. Then this point, you trace it down to the horizontal. This point, trace it down to the horizontal using broken lines. This point, trace it down to the vertical side. So this will now be your y2, y1, and this will be your x2, x1. So by the time you have done this, make sure you put delta, whatever is on the vertical. You can use y also, since you have put y here, you can put delta y here, put delta x here. Please take note of that. Now, you now go to the page where you want to calculate your slope. Slope equals to, the first thing you write delta y over delta x. It's a point. If you don't write this delta y here and delta x here, you have lost a mark. If you come here, you don't write this first, you have lost a mark. So the next thing, you write delta, whatever is on the vertical. In this case, it is mass. That's delta mass over, on the horizontal, in this case, is capital T square. Delta T square. So then the next thing, you write y2 minus y1 over x2 minus x1. It's very important. So when you have done this, you have already captured possibly all the marks for the graph. So finally, when you get the value for your graph, for your slope rather, your slope must be in 3 significant figures. Please take note of that. 3 significant figures. And your slope may have unit, may not have unit, depending on what you have on the vertical and horizontal. For example, in this case, mass is on the vertical, which is in grams. T square is on the horizontal, which is in what? In seconds square. So what does that mean? That means that it's going to have a slope, and that slope will be grams per second square. Grams from the vertical, second square from the horizontal. Grams per second square. That will now be the unit for the slope in this my assumed graph. So that means if resistance is on the vertical and current is on the horizontal, the unit of the slope will be ohms per amperes, which will be the unit for the slope. Ohms from the vertical resistance and amperes from the horizontal current. That is if it is not this mass and the T square. With this, I can assure you that you can't lose any mark. I wish you all the best. Bye for now.